Beam design procedure. Once the initial member sizing of all the member is done, the structure could be modeled and designed as per the loading requirement. Structure analysis may be done manually or using a computer program. If it is a simple beam like a simply supported beam, the calculation is much easier. It can be done manually. However, when it becomes more complex, the use of the software will be done to save time required. After find the bending moment and shear force, the design of the beam can be done as per the word, example and explanation given in the relevant code. First, we have to assume the section size, grade of steel and concrete according to the structure to be built. After that, we calculate the total UDL, point load and other loads if applicable. And then we calculate the fractional moment, revise the size and grade of material if required, calculate the area of steel required, and provide the reinforcement detail. That's all for the beam procedure.
Hi, my name is Siti Kasina binti Subarman, and I would like to talk about the column design procedure. For column design procedure, columns are vertical components that carry axial compression load and are prone to buckling due to their slenderness. The column behavior will be determined by its slenderness as the resistance of a compression component reduces as its length increases. So the slenderness ratio is the ratio of a column length to its cross-section's minimum radius of gyration. To design the column, first we will start by determining the design life, exposure class and fire resistance based on the Eurocode 1990 table 2.1, Eurocode 199211 table 4.1, and Eurocode 199212 section 5.6. And after that, we will determine the material strength by following the British Standard Act 5001 table A.3 and Eurocode 2061 table F1. And after that, we will select the size of column based on table Eurocode 199212 table 5.5. After that, we will calculate the minimum cover for durability, fire and burn requirement based on Eurocode 199211 section 4.41. After that, we will analyze the structure to obtain critical moments and axial force by referring to Eurocode 199211 section 5. After that, we will check the slenderness by following the requirement based on Eurocode 199211 section 5.8.3. And lastly, we will determine the final design moment based on Eurocode 199211 section 5.8.8. After we determine the final design moment, we need to determine the area of reinforcement requirement by following the Eurocode 199211 section 6.1. And after that, we will end it with the detailing by referring to Eurocode 199211 section 8 and 9. And that's the end of our column design procedure.
Assalamualaikum. My name is Shifa Nabila binti Zulkifli, AF 190150 Aura. I will present about analysis using software StartGroup. Firstly, I will connected the node and the beam from the layout provided at project instruction, and then I will insert the load cases. First is GK, which is consists of safe weight, member load, of uniform force, and then floor load. Meanwhile, for the load cases 2 is QK, which is 3.5. This is the 2D analysis for the shear at Z and Y axis and beam stress.
Assalamualaikum warahmatullahi wabarakatuh. My name is Aminah Fia Bita Adalim with metric number F190272. I'm going to present about truss design procedure. So for truss design procedure, first is we have to choose the type of truss, and then line diagram of the truss is sketched, and depending on the span, the amount of lighting required and the roofing material that is available. And then we use the guideline of 1S875 where load acting over the truss are calculated in part 1 to 5. Then after that, we calculate the load acting on the truss at the pulling point are computed and the pulling are designed. The pulling was created through the process right and error. And then we force acting on the member of various load combination are evaluated after the roof truss. We analysis for the various combination using the graphical, the method of section, the method of joint, or by computer program. And then the next step is under a specific set of load, each member may be subjected to be maximum compressive or tensile force. And then the top chart will experience bending moment in addition to axial compression when the pulling are positioned at the intermediate points or between the top coordinates. As a continuous member thereafter, the bending moment may be determined using any method that is appropriate, such as movement distribution, computer program, and another. And then, in order to prevent asymmetry, the member that come together at joint are sized such as their coordinate axes meet at the same location. Using the matrix stiffness analysis program or the strain energy method, the maximum deflection of the truss can be calculated, less than the deflection specified in table C of the code with the computed deflection. And then the material take-off is calculated and the detail and fabrication drawing are prepared. Next, the lateral bracing are created in necessary to use a computer analysis program when cross-banded wine grinder is used by the truss when unnecessary. It is common practice to discredit the compression DNR and believe that the tension DNR are responsible for the pernicious. The primary compression member is thereafter and double angle if the equal angle is frequently preferred. Similar compression during handling or wind action may be experienced by the main ties. Double angle sections are also better suited for these main ties because they frequently have a long, unsupported lengths. The truss are weak when they are out of the plane but stiff when they are in it. That's all. Thank you. Firstly, we need to check the area of the flat. It can be in the work of such a lot. It to be larger or equal to the required area of the flat. Secondly, we check the required area of the flat from check 1, which is smaller or equal to the effective area. Thirdly, we check the flat thickness is larger than the minimum flat thickness required. Fourth, we check the resistance of the wall and arrange the wall mount in suitable placement.